Ladies and gentlemen, if you would like to continue the discussion with each other, please go carrying on networking in the downstairs in the networking area. But we're going to move on with our program now. Next up, ladies and gentlemen, please now join me in welcoming our next panel, Dr. Yervant Zorian, Chief Architect and Fellow of Synopsys and President of Synopsys Armenia. Our moderator for this discussion will be Mr. Rafi Kasarjian, CEO and Principal Advisor at Sensian. I'm sure it will be a fascinating discussion. So, round of applause, please, for our next panel.
Okay, thank you everybody for coming to this panel. It's very exciting for me because, you know, I've spent most of my time in the software side of things in the tech industry. It's nice to be talking about hardware, especially with the great setup that we've gotten with Rev's talk earlier today. So I want to give as context, and actually Rev covered some of this, but I think it's very important. And before I introduce Dr. Zorian, talk a little about the very briefly about the history of semiconductors. You know, the reason Silicon Valley is called Silicon Valley is because of silicon wafers, right? So the very first startup in Silicon Valley was Shockley Semiconductor Labs, which are a bunch of people that came out of Bell Labs. And then 8 people defected from Shockley to Fairchild, and then Fairchild eventually became Intel. And we all know the story about Intel. And what's interesting is that for the first 30 years, probably, from the actually 20 years or so, there was significant accelerated growth in the power of silicon and semiconductors to drive technological advancement. And Rev talked about Moore's Law today, and that, you know, the amount of computing power would double every year, or every year and a half practically, and that went for a very long time. And, you know, those of you that are old enough remember the Intel series of CPUs, 286, 386, 486, and then the big news around Pentium. And there was a lot of excitement. Intel was by far the leader, and the combination of Intel and Microsoft, or Windows, called Wintel, kind of led the PC industry for some time. And then we had kind of a shift. We had a shift as the cloud came about, and then actually first the whole, you know, social networks and Web 2.0, the internet, and when the focus shifted away from PCs and towards other infrastructures, the focus on CPUs kind of waned at the same time as there was so much advancement that we were kind of reaching, as you saw on Rev's chart, the amount of advancement that could take place in terms of cramming more and more transistors onto a single silicon wafer. So we had kind of this, you know, people were no longer believing in the power of hardware. Even Mark Andreessen said, you know, software is eating the world. And now that's from a layman's perspective, and I'm sure Dr. Zorian will let us know. I think semiconductors, even during that period, proliferated to all kinds of different devices. And so it wasn't that the semiconductor industry died, but from a public perception perspective, it wasn't the same. Then we had a little thing called ChatGPT, which again was referred to earlier, right? And the incredible computing power that a different approach to developing these processing units, called graphical processing units, brought to all kinds of innovation. And all of a sudden, basically, the GPUs and the hardware designed to drive advancements in AI is at the forefront. And that's what we want to talk about today with Dr. Zorian. Dr. Yervant Zorian, a good friend. I think we've shared the stage many times before. As was mentioned, is the chief architect of Synopsys and the president of Synopsys Armenia. And interestingly enough, Dr. Zorian spent the first 10 years of his career at Bell Labs, which is where all of this stuff around silicon started so many years ago. So Yervant, with that background as context, let's talk about kind of what has been the recent impact of AI on the semiconductor industry. I mean, I think Synopsys plays an interesting role because if, let's say, NVIDIA and Intel and the other chip manufacturers are kind of the main armies fighting each other, companies like Synopsys are the ones like the arms merchants, right? You're providing technologies for these chip designers to be able to innovate. So maybe you could talk about sort of how you see how AI has impacted the industry.
Absolutely. Thanks, Rafi, for the introduction. Hello, everybody. It's an exciting event. Semiconductors have been, in the past 50 years, the backbone of electronics. Anything we use is based on semiconductors. So it's not new that semiconductors are playing a key role. But as Rafi said, initially building CPUs, initially building memories, building certain application chips, and today building AI accelerators. Now, AI is not new. We heard it this morning as well. AI was there in the 80s, the 90s. I myself was programming in Lisp when I was doing my PhD. Now, AI did not reach its peak during that time. Why? While we knew the algorithms, while we knew that we have to use certain knowledge there, learn from data, and go forward, AI was lacking two things. Was lacking data and was lacking speed. And as we build up the data, as we started collecting more and more data, and the more data you have, the more precise your AI result is, because it's based on prior experiences. And in the 2000 era, we had enough data, but the speed was not there, because AI was using software only. We needed to have a hardware, an accelerated hardware, a hardware that thinks like our minds in a neural network. CPUs are not neural networks. CPUs are concentrated computation engines, where you have to go through very high speed to be able to do. Whereas with GPUs, and that's what NVIDIA did, AMD, and now today with many other AI acceleration chips, we build neural networks. That is, we distribute the task over a number of neurons, and that's why the semiconductor industry played a key role in making AI happen today. And in fact, as semiconductor industry with Moore's law started to speed up every year and a half, doubling the speed, and so on. Now, we reached a point where with that double of speed, we are able to do deep learning. Until 2014, the learning was shallow. The layers of neural network were limited, up to 8 layers, 9 layers. Since 2014, we exceeded. We started to do over 10 layers. Today, we have thousands of layers of learning, of neural networks. That's why we call it deep learning. That's why we can do a lot in parallel, not only in a single machine, but many parallel machines at the same time when you do the learning. And all of that is because of these new powerful GPUs that use today's technology of 3 nanometer. So that makes it happen. That deep learning gives us precision in what we do. For instance, back in 2014, when we moved to deep learning, suddenly our image processing, one of the applications, we do language, we do image processing started to be better than the human image recognition. Our human image recognition is, on the average, 96% correct. So there's a place of 4% mistakes with human image knowledge.
That's still pretty good. 4% is, 96% is still pretty good.
So when we did deep learning, we crossed that. We crossed to AI become 3%, 2%, and now it's at the 1% level in terms of error, which is much better than 4% error.
Very good. So getting back to kind of the industry makeup, right? When we had Intel that was dominating, then AMD was kind of the, was Coke and Pepsi, and then NVIDIA came out of nowhere with GPUs. Now we have all of the major tech companies getting into custom semiconductor design and if not, not self-production, but at least, manufactured production. And, we talked about, we both talked about going from CPUs to GPUs. Google came up with tensor processing units, which is kind of a different way to do this. And now they're talking about neural processing units as being so what does that mean for companies like you that are responsible for developing the tools they use, and not just your sort of longtime customers like like Intel and AMD and others, but these new era of customers like Meta, like Apple. Apple's been doing it for a while, but Meta and Amazon and some of these other companies.
Good question. Thanks, Rafi. It made a difference for us in at least 2 ways. If I look at what we do in our companies, we provide chip design tools. So if you are a chip designer, you need software tools to do your chip. From your concept up to the manufacturing level, you go through multiple stages. Now, we have done this for over 30 years now. when the chips were smaller, it was possible to build your software tools stage by stage and make it such that you can contain the kind of transistors that you will do with algorithmic-based tools. Today, that's not possible anymore. Why? Because number of transistors kept increasing. We had 1,000 transistors per chip, 10,000, 100,000. Today's chips have 500 billion transistors. 500 billion transistors, that is. Now, to design a chip with 500 billion transistors, humanly is impossible. So that's where our first AI contribution was, where we started using AI in our chip design tools. So every tool from the top level to the bottom level has a co-pilot, has an AI assistant. If I'm doing simulation, if I'm doing verification, if I'm doing testability, in every case I have to bring in my co-pilot, and AI is helping us design chips. So today's chips cannot be designed without the AI co-pilots at every stage. This is one contribution we had. The second one is our contribution to the chips that need AI, because AI is hardware after all, and we provide building blocks for the chips. Whether the entire chip is AI accelerator, such as the ones that you mentioned from Google, from Amazon, from Meta. Also, many other chips have a corner of AI. If you are at the edge, think of the world as cloud and edge, right? At the cloud level, where Amazon and Alibaba and Google are providing big accelerators, the entire chip will do AI for you. At the edge, your car, your self-driving chip has a corner of AI in it, okay? That corner of AI is also, so we have to provide those engines, those building blocks. So we, as Synopsys, also we create building blocks for AI so that our users can incorporate them into their applications, whether in the cloud for hyperscalers, or for high-speed computing, or in the edge at different levels where intelligence is at the edge, such as self-driving cars, robots, drones, and so on.
Very good. So actually, this is a case of the technology you helped develop led to AI, which then is now you're using to help generate the next set of tools. So a question came up earlier today about from Richard about kind of the equity of using AI in different contexts between the developed world and the developing world. I don't want to touch on the concept of equity, but I would like to touch on the concept of energy consumption, because we're now hearing all of these stories of all of these large technology companies wanting to build their AI, data centers, these huge data centers next to actual large, power generating stations, which can obviously impact the environment in a negative way. When you talk about having AI tools or tools that you use for chip design, do your tools take into account kind of the energy efficiency that's going to be part of the chip? And do you see any hope for us that we'll be able to create chips that are less consuming so that we don't have these huge data centers sucking up all of the energy that should be used for other purposes?
Yes, Afi, absolutely. In a couple of ways. So yes, power consumption, power dissipation is a huge thing. They're not only close to the power stations, also they are close to water. There's the cooling aspect of it is very important. When you're running AI chips, it is the center of the AI chip is hotter than a nuclear power center engine. So you're consuming lots of power. Now, if we do it blindly, we'll consume lots of energy. If we do it in a generic way, we'll consume lots of energy. What's happening today is we are optimizing. On one hand, doing low power design, that is using power exactly where necessary, but not everywhere in one aspect. So low power design is very important from the architecture level down to the circuit level. So our tools, those helpers of yours, the co-pilots, do lots of low power design. But not only that, also the utilization of the AI chips are different from one application to the other. So the flow, the usage of the chip is different. If you can concentrate on exactly what is needed, you consume less power. If Meta is using AI in its chip, it has certain things that's optimizing because the AI usage in the Meta chip is different. Let's say if they're using it for social media versus you're doing it for search in Google. So if you optimize your AI chips, in each case, you can consume less power. That's exactly the reason why Meta has different AI chips, Amazon is doing its own, others are doing their own, because their usage, their utilization algorithms are different from each other.
Very good. Now back to the adoption of AI tools among your own engineers to help accelerate their work. And I'm going to shift a little bit the focus to Synopsys Armenia. Right? You know, from a very personal perspective, you know, when I'm typing something in Google and it automatically brings the other words, you know, they sort of suggests words for me to use, and I hate that, right? I don't want the machine to be doing my thinking for me. Did you get that kind of resistance from your engineers at first, saying that these tools are kind of replacing what I do, or did, you know, that's one side of the coin, the other side of the coin is, oh, this helps me become more efficient and work faster, and how did you sort of manage that transition?
Actually, it's the second. It's the second because if you are becoming more efficient, if you're creating more optimal solutions, our engineers and their users, their customers, will benefit from it. Yes, maybe in our regular life, when we are searching for information and so on, we like to have more control. But when you are creating a very complex design, and in that complex design, an AI helper under the hood is providing you optimization, that's very helpful. So we see a good utilization of that. In fact, many of our tools that we do here at Synopsys Armenia utilize AI in them. So we create it here in order to optimize our solutions as we go forward.
Again, sticking to Armenia, I mean, I think actually the chip design software industry was one of the initial drivers of growth for the Armenian tech industry, right? I mean, Ponte Solutions, Hyperion, and then Virage Logic, Synopsys, Mentor, Siemens, you know, a lot. So we've got a long series of these global companies that had significant operations here. Now, I remember when I first got here, you know, you sort of, if you got a job at Synopsys or Mentor, this was kind of the best career path for you. You're going to be there for a long time. You work for a Western company. You have a decent salary. And over time, you kind of saw, you know, these new generation of startups, like a Pixart, like a Crisp, and these other companies. And there was this, you know, tug of war and a competition for talent. Now that chip design is again at the forefront, two parts to this question. One is, how much of that sort of leading edge or bleeding edge innovation within Synopsys is taking place in Armenia? And are you finding now that there's more interest sort of among the general public on AI and the things that drive AI, that it's making it easier for you to hire the next generation of talent or keep the talent that you have?
Chip design itself, as we said, it requires AI. So having that in is important. Armenia plays a key role in that. That is true. Historically, we started doing parts of our companies, initially bringing startups from Silicon Valley to here. Few that you mentioned, our startups were created mainly in Silicon Valley with R&D centers in Armenia, growing faster. And then our multinationals, such as Synopsys or Siemens, came to have its locations. So that's why we saw that growth and stability is starting from startups to the larger companies. Now, talents. Talents are not only limited in Armenia. We all know that we have limitation of talents in Armenia. But it's a worldwide problem. It's a worldwide problem to see that we don't have enough talents in general in technology, but particularly in chip design. Today, companies are going to every corner of the world. They're going to, I don't know, to Vietnam, to the Philippines, to Malaysia, to Sri Lanka, to find talents. We did find talents in Armenia. We created a nice discipline of education, and we have a pipeline of that. But lack of talents is key. Now, how much AI is helping? AI is helping in creating our solutions. Otherwise, it wouldn't. So companies that have high valuation from AI in the market looks at them as if they are utilizing AI to improve their efficiency. That is, with the same number of people, you have to create more value. Why? Because you are utilizing AI in it. So that is part of what we do.
Okay, very good, very good. Shifting a little bit to sort of more the geopolitical side of semiconductor design and semiconductor manufacturing. So given the increasing US and now European concerns about sort of the China having its own very advanced semiconductor capabilities and putting all kinds of restrictions in place from a tech transfer perspective, from in other areas, what does that mean for the way a company like Synopsys operates globally, and what does it mean for the way you operate in Armenia? Let me talk a little bit about that.
Yes. Our industry at large, the semiconductor industry, has been a global industry since its beginning. Okay? So there were no barriers. Until 5 years ago, everything was done in a very complementary way. You create a design here, you create a building block there, you create a tool somewhere else, you manufacture the chip in Taiwan, in Korea, you do the packaging in Singapore, Malaysia, then you do the testing somewhere else. So it is very well structured globally. And that went very well. Until what you mentioned, this geopolitical situation with China, where China was benefiting from that global chain, and then in that global chain, found out that we can do a lot with many important Chinese companies. And then the restrictions started to come up in order not to enable those to happen as easily, to delay them at least. So restrictions. And in those restrictions, we found out soon that there's so much dependencies or interdependencies between countries, between regions. And today's mode of operation is to create sovereignty in regions. So the CHIPS Act that we see, which started from China, putting a huge amount of budget to create a CHIPS Act of China, to create designs in China, to create manufacturing in China. Reciprocally, US created its own CHIPS Act. We have put $52 billion to consume in order to have self-contained, sovereign chip design and manufacturing in the US. Europe reacted to that. They have 42 billion euros budget, the governments, feeding the companies, bringing manufacturing, making more advanced designs. The same thing in Japan. We have a CHIPS Act in Japan, in Korea. So now we have sovereign entities in various places. It is good for us as a company because we see that we have various places that we have to contribute to. That's good. But on the other side, this global chain is getting dismantled, and the problem is coming up. And the problem is, again, talents. We don't have enough talents, enough expertise to feed each region. Because we were interdependent, we used to use different groups of people. Now, the US is lacking 1 million experts. Not a small number.
One third of the population of Armenia.
Yes. Europe is TSMC, which agreed to come and open a factory in Oregon. They had to postpone their factory opening by a year because they were not finding people to work in the factory. Others, the same thing. So talent development is becoming a very serious issue. So all of us have to work on the talent development aspect. In the US, the CHIPS Act is feeding different regions, universities, and companies together, doing talent development. In Europe, the same thing. Now, back to Armenia. In Armenia, we were successful in the past 20 years. Synopsys is here for 20 years. And the way we were successful, the way we were able to grow from few hundred people to now 1,300 people, very good experts, was because we did this development of talents in Armenia, partnering with universities, having bachelor programs in chip design, master's program, PhDs. So that template, that experience existed here, whereas in other countries it did not exist. And it is such that you prepare your talents that at the door, at the graduation, they are already chip designers. You don't need to train them further a year or two to make them productive. Whereas universities at large in the world, they cannot do that. So our method of preparation, preparing the talents properly, now is being used elsewhere. So Armenia is being acknowledged as a talent development model that the US and Europe can mimic. And we're participating in the CHIPS Act of Europe, Japan as well, and the US, in providing our method, in providing our templates, our courses, our methodology, our tools, our IP, to make that happen as well. So we are contributing to the CHIPS Act at large.
Excellent. You know, this is what you get when you have, you know, we talked a little bit earlier about the power of the Armenian diaspora. When you have, you know, key people like the chief architect of a multinational corporation at the heart of what's happening in the next generation of chip design, these are the kinds of things that we can bring to this country. This, I think, is a good segue, and I don't know how we're doing on time. I don't have a timer anywhere. But as you look ahead, Yervant,
yes.
and, you know, we're in the middle of this GPU wave. We're also in the middle of something that's talked about a lot less that we touched on earlier, which is the incorporation of all kinds of semiconductors and chips into all kinds of appliances. They don't all have to be, you know, these huge inference, you know, engines for OpenAI or ChatGPT. Where do you see your industry going in general for a company like Synopsys? And again, more particularly, what does that mean for Armenia? Do you think that there's going to be a need to overhaul the educational programs you've set with the various universities? Do you think that we need to bring in talent from outside to work with talent here? Sort of where should we place our place our bets as a country on, given where the industry is going as you see it?
Thanks. Yeah, I'll take both. And remind me if I forgot the second. Okay, so if you look at the trends are such that, yes, the chips are everywhere, that prominence will continue, but not only in the complex areas, not only in hyperscalers, high-speed computing in the cloud, not only in the very intelligent self-driving cars, but everything we touch, if not today, will be smart and connected. We call that IoT. IoT is Internet of Things, where the smartness is in your pen, in your glass, in your shoes, in anything you do. That smartness is important. So we can participate in that. We don't need to be necessarily in the data center. We can be in an eyeglass. We can be in various places. Now, that is one aspect of it. The second aspect that we're seeing, again, a nice trend, that is the combination of the hardware, software to create your solutions. That is configurable systems. When I buy my car, which has certain features, I don't stop at that level. 2 weeks later, I have more features. Software upgrade. 3 weeks later, I have another set of features, and so on and so forth. My car is continuously over-the-air upgraded into new features, as your phone does today, your mobile equipment, as your computer does. So every equipment that is smart and connected will be reconfigurable. So nothing is fixed when you buy it. So you'll be able to keep augmenting, keep upgrading, which gives us lots of opportunities to bring the software on top of the hardware and make it configurable and programmable. That's a trend. We will see more of it in the future as well.
So that means, though, but the actual hardware in these devices, because you're not going to change your car every other year typically, like they're upgradable over the year, right? And but you have to think ahead to make them.
You have to plan ahead.
Exactly.
Tesla plans ahead that certain things will be changed over time, so you can keep optimizing. So your chips and your system is reprogrammable, configurable. So these are certain trends that we have to be part of. Now coming to Armenia. Armenia is already in its place, but Armenia in general as a society and technology sector need to be further involved in today's technology. I say the two because you can be user of technology, you can be creator of technology. So as users, we have to understand where we are. AI is a big trend and it's a way of thinking. If we are not well prepared to think about data, utilization of data, doing data sciences, selecting the right data and not the wrong data to do your decisions, you will not be able to utilize it much. So the way of thinking in terms of data science, in terms of AI, has to start from early stage. That's why I believe our AI utilization is not only at Synopsys. We have to start from schools. We're preparing the students for that. That's why today, for instance, again, us as Synopsys Foundation, we are feeding a program for teaching AI in the schools. And we have created a very nice program for 3 years, 10th grade, 11th, and 12th grade, so 3-year program at high school level, to prepare kids with AI knowledge to do Python programming, to think of it as data, and just after 3 days, we have a graduation of the second group of that. In fact, we're doing that in a scalable manner. Scalable in the sense that instead of physically putting it in a couple of schools, we're doing the teaching virtually in e-learning. That's why we have partnered with the Armenian Virtual College, an HBU project that you know of. The Armenian Virtual College, which was created for other purposes, today it's doing AI teaching. So in an e-learning manner, in order to reach every school in every region, if possible, every village, if needed. So therefore, scalability becomes important because we don't want to limit AI to certain places only. Now, in Armenia, again, it's not only AI. We have to augment our abilities in STEM at large. So I'd like to complete my response in emphasizing the importance of education. So education in STEM, education in AI, it has to start as early as possible, complement it at the university level, and continue training throughout lifetime, because things don't stop. Each one of us are students for a lifetime. Every year, every month, I learn new things, and I utilize it in what I do. So we have to be open in our minds to continue learning as we move forward.
That was a very excellent end to our panel, and literally we're at 2:10 seconds. So my AI assistant got us here right on time. Thank you very much, Yervant. As usual, it was a true pleasure. I hope you all enjoyed it, and I hope you enjoy the rest of the conference. Thank you.